Come on! Lost again. Curse you, Johnny Boy 328! Oh, wrong. Hello. Welcome to Learning Hurts. I'm Joe Smitzleton. Today we're going to be talking about something that you've probably heard of before. In fact, it's all over the world. It's called colorblindness. The first thing you'll want to know about colorblindness is, well, what it is. It's quite simple, really. Colorblindness is the defect in humans which makes them unable to see certain colors, or rather, tell them apart. The most common form of this is not being able to tell the difference between red and green. Right there in the center is the normal color vision, but yet surrounding it are different types of vision seen by people all around the world. First, let's talk about risk factors. Well, when we're talking about colorblindness, this disorder is mostly inherited by males. That's right, if you're a male and one of your parents, or both, has colorblindness, I wouldn't want to be you. I think I've drone on with this whole subject of risk factors for what, 25 seconds? That's a lot. Let's talk about how you inherit colorblindness. Colorblindness is inherited on the X chromosome, so if you have a Y chromosome, it won't have colorblindness, but if you have an X chromosome, it might. And this is precisely why men have a far greater chance of inheriting colorblindness than women. As you can see, the unaffected father and carrier mother produced an affected son, a carrier daughter, and two unaffected children. This is because the carrier daughter received a dominant and recessive X chromosome. The recessive was the one with the disorder, and the dominant X chromosome overrid the recessive X chromosome. But because the affected son only has one X chromosome, and that's the defected recessive X chromosome, he has the disorder. Mitosis is the process in which cells undergo reproduction, and DNA also replicates and divides, with one strand for each new cell. But with colorblindness, something messes up in mitosis. We're just going to stick with the red and green example for now, keep it simple. Now, red and green receptors capable of seeing red and green light are located on opposite ends of the same chromosome. So, during crossover, when chromosomes trade genetic information with each other, sometimes one chromosome ends up with no green receptors and the other ends up with two. So, the child produced from the chromosome with 0 green receptors has no green receptors at all, obviously, which makes no green cones, which makes no green light. So, that is how chromosomes and mitosis play a part in colorblindness. Now, you may be wondering, what causes colorblindness? Well, I'll tell you, good sir, in good time. And that good time is right now. So let's start. There are 3 cones that let you see color. Red, blue, and green. And they let you see also mixtures of those colors as well. But with colorblindness, sometimes you don't have one of those cones, or 2 of them. The picture of the cone on the left has all 3 cones, green, red, and blue, in that order. But the picture of the cone on the right has only the red and the green cones. This means that person is colorblind and cannot see the color blue. You see, when rods and cones are struck by light, and rods also help you see light, they release certain chemicals which allow you to see the light. But when one or more of the cones is damaged, or not there, you can't see those colors. Now it's time for Fun Facts! Did you know that red and green colorblindness is also referred to as deuteranopia? Did you know that when somebody doesn't have any cones at all, or they're all malfunctioning, everything appears in shades of gray? And did you know there's a type of colorblindness that lets people see things in good light, but not bad light? Well, it's great that you know now, but we're going to talk about something completely different now, so let's keep going. Colorblindness's symptoms are simple. You can't tell certain colors apart. Now, in order to be tested for colorblindness, the person who is thought to have colorblindness is shown a picture full of colored dots. The colored dots that make up the object in the circle are different shades of one color, while the circles that make up the background of the image are different shades of another color. The numbers are 7, 6, 26, 73, 74, and 45. If you cannot see one of those numbers, you have that type of color blindness. Now, when you can't see every color in the rainbow, and when you envy your friend because you can't tell what flavor Skittles he's eating, life can be rough. Look at all those sweet, juicy colors. Well, when you have color blindness, you can't see most of those. So people recognize colors in different ways instead, like taking For example, the traffic light. People always remember that red is on the top, green is on the bottom, and yellow is smack dab in the middle. Food may look gross and disgusting to you because they have a weird color, and you may use wrong colors when you're painting. So your sea could look orange, your grass can look blue, and your sky could be a greenish purple. And lastly, there is no treatment for colorblindness. I'm so sorry. And now it's time for my 15-second summary. Colorblindness is the inability to tell two colors apart, and it usually affects males, and it's always on the X chromosome. It's because cones have the inability to reflect light because they are not there or they are malfunctioning. Colorblindness is detected by a simple colorblindness test. People have awkward lives with colorblindness, and there's no treatment currently available for colorblindness. I guess it's the end of our show. It was nice having a one-sided conversation with you. I'm Joe Smitzleton, and this is Learning Hurts.